Hi everyone. Today we'll talk about one of the NoSQL platforms called Neo4J. My name is Min and my other teammates are Rory, Paul, and Tyler. I hope you enjoy this video. So Neo4j is an open source NoSQL native graph database that provides a transactional backend for your applications. It is initially developed in 2003 and it has been publicly available since 2007. This platform gives developers and data scientists the most trusted and advanced tools that is used to build today's intelligent applications and machine learning workflows. Neo4j is implemented in Java and is accessible from software written in other languages using the Cypher query language through a transactional HTTP endpoint or through a binary bolt protocol. So here's a backstory of how Neo4j was created. Neo4j was first created as an embedded Java database. This is where that 4j in the name comes from. And it has since evolved beyond that. So the 4j in Java aspect is no longer really relevant today, but it is a nod to its history. Neo4j was created to address some problems that the founders were having in building a content management system, CMS, specifically for some of the rights and metadata around the usage of photos. And they found it very difficult to represent in a relational database because all of the different connections and relationships and also the richness of the data. So that's why Neo4j was first created. And then the founders quickly realized that there were lots of other interesting use cases beyond just this embedded database in the CMS application. So Neo4j quickly evolved into a more generalized system. There was a rapid uptake of Neo4j where it was being used for generating personalized recommendations as well as handling logistics and routing. It was also popular for dealing with complex access patterns inherent in things like identity or access management or fraud detection, etc. So what is a graph database? A graph is a pictorial presentation of a set of objects where some pairs of objects are connected by links. It is composed of two elements, nodes, or in other words, vertices, and relationships, or called edges. Here, the nodes of the graph depict the entities, while the relationship depict the association of these nodes. Neo4j is a popular graph database, and there are other graph databases. Some of them are Oracle NoSQL database, OrientDB, Cypher GraphDB, GraphBase, etc. So why do we use graph databases? And nowadays, most of the data exists in the form of the relationship between different objects and more often the relationship between data, which is more valuable than the data itself. Relational databases store highly structured data, which has several records storing the same type of data, so they can be used to store structured data, and they do not store the relationships between data. And unlike other databases, graph databases store the relationships and the connections at first-class entities. And one good thing about Neo4j is that the flexibility you have with the data model. You still need to think about how your data elements are related to each other, but it doesn't have to be perfect. You don't have to declare your schema intentions ahead of loading data, which allows you to get the data in as quickly as possible and then test that hypothesis straight away. If you want to know the differences between relational databases and graph database, here are some examples. So tables in relational database becomes graphs, rows becomes nodes, and joins turn into tuples, etc. And so Neo4j is available both as a standalone server or an embeddable component. You can download it or try it online. Here's a quick demonstration of how to download the software to your desktop. So first, you can go to Neo4j website and click on download. This will redirect you to a page where you can download Neo4j on your desktop. And you can click on download. And then it will take you to a page where you have to fill out your name, last name, and for this case, I'm just gonna take my personal email address, and I guess I just put in Texas Christian University. Country is in United States. And then click on download desktop. Oh, and then we have to put Texas. And then that will download Neo4J directly to your desktop. And then they'll give you a key. And if you keep following the instructions they have, you'll be able to install Neo4J desktop on your laptop and start using it right away. And we can also use Neo4J without download. So we can use Neo4J sandbox to start a project in under 60 seconds, no download required. And they also have some sample projects for you to get more hands-on experience with the platform. And they have fake data sets such as movies in the first one, where you can learn Cypher with the movie database involving connections between actors, directors, and movies. Or you can have a database about network and IT management, or this is where you can start with crime investigation, or for the use case of fraud detection that I mentioned earlier. So now that we have the software on our personal computer, let's see what the platform looks like. So Neo4J is a Neo4J graph database is the core of the platform, leverages not only data, but also data relationships, connecting data, enabling queries at an outstanding speed. The platform includes Neo4J Graph Data Science Library, the leading enterprise-ready analytics workspace for graph data, and the graph visualization and exploration tool called Bloom, the Cypher query language, and numerous tools, integrations, and connectors to help developers and data scientists build graph-based solutions with ease. So the graph shows the components of the Neo4j graph platforms. Let's take a look at the graph. At the core is the Neo4j graph database, and surrounding it are some of the tooling, use cases, and audience. First, let's have a look at how the graph database, specifically Neo4j, are different from other databases such as relational, document, and so forth. So one of the core differences, the advantages of Neo4j is a property graph data model. All of the contact points are graph-based: the thinking, the modeling, the querying, and the storing. The graph database consists of entities called nodes, and the connections can join them together or called relationships. And importantly, relationships are first-class citizen of the data model, and this is represented in how we store and query them in the database. So speaking of storing and querying, we use a query language called Cypher to work with Neo4j. If you're familiar with relational databases and SQL, you can think of Cypher as SQL for graphs, focused on pattern matching. It is a query language that features ASC2R patterns. As Neo4j is optimized for traversing the graph, the query reflects this traveling from node to node by following relationships. You often see queries describing patterns traversing through relationships, maybe 10 to 12 or even unspecified variable length patterns. Neo4j does this through a concept called index-free adjacency. When moving from one node to the next, rather than doing an index lookup operation to do the traversal, the database will look up the pointer for the next hop, which computers are very good at. And then the implication of this is that performance of traversals are not dependent on the overall size of the data. A local graph traversal go from one node following a chain of relationship is not dependent on the overall size of the graph. be it maybe it's small or large. Now compare this concept to a relational database, where the equivalent would be table joins. Indexes are used to see where two tables overlap to join them. This index-backed operation performance is based on the size of these two tables. And as the tables grow, the performance is going to be impacted. So you often hear the term graph native, and this is fundamentally what it means. It's about optimizing all the way through the stack from the data model to the query language, and then exploring how that data is stored on disk and how the database process it is optimized for the graph and the graph workload. So that's what graph native means when you hear that term. Neo4j database is also very extensible. You have the ability to write user-defined procedures, functions, and plugins to define custom logic beyond Cypher. And this also forms the basis for other interesting components within the graph platforms, which we will cover later. So overall, the platform includes Neo4j Graph Data Science Library, Neo4j Bloom, Cypher Query Language, integrations, and connections. And let's dive into the details of each of them. First, for the Neo4j Graph Database Library, one of the most interesting pieces of the platform is the library. The reason is that the library allows you to run graph algorithm in Neo4j, such as centrally, PageRank, and community detection algorithms to find communities and clusters in the group. And these are also form the basis for more advanced techniques that feed into machine learning or into our artificial intelligence pipelines. It is a graph catalog that creates an efficient analytics workplace. Specifically, it utilizes the relationships and network structure in data with particular purposes, such as helping data scientists address complex questions about system dynamics or group behavior, or building essential predictions and easily reshaping data with one command through simplified syntax. Next is Neo4j Bloom. Neo4j Bloom is another graph app that allows you to visualize and explore your data using near natural language. And what does that mean? If you have a good understanding of your data model and your domain, you don't really need to know any Cypher to be able to go off and investigate your data. Bloom will investigate the data in your database and do some sampling and build out a view based on elements such as labels or relationship types. It has a lot of flexibility around how it is interpreted. You can enter an approximation of a label or property that you're looking for, and Bloom will find it for you, along with the patterns, allowing you to visually explore your data. You can further customize your Bloom environment with icons, colors, or sizing. And with common phrases, you can turn these into search phrases, which enables you to use a full power of Cypher for repeatable searches and with a friendly command. And all of these features together allow you to share the same perspective within a team or department, making it easy to discuss and explore discoveries and so forth. What makes Bloom even more powerful is that it works really well with graph data science, and you have the option to further tailor your perspective. You can do things such as PageRank, where you're looking for influential nodes, and then dynamically size them based on their range of influence. Or you can also display hierarchies. All these factors make Bloom a very fantastic visual aid for data scientists. And another one is Cypher, the graph query language that we have mentioned for quite a few times during the presentation. And it is the powerful graph optimized query language that understands and takes different stored connections, not relationships. And then the fourth one is Neo4j connectors and integrations. Neo4j offers connectors and integrations to help bring together most important workflows. From data migration to transformation, the user can create a graph data pipeline, which enhances existing tooling with graph data and feed into Neo4j. Neo4j connectors offer scalable, enterprise-ready methods to hook up Neo4j to popular data orchestration and processing tools. And several connectors for Neo4j facilitation are Apache Spark, Kafka, and BI and lab integrations, and they're all free to use.
Next, we'll be talking about use cases for Neo4j. Our first one is fraud detection and analytics. Traditional fraud protection measures focus on discrete data points such as specific accounts, individuals, devices, or IP addresses. However, today's sophisticated fraudsters escape detection by forming fraud rings comprised of stolen and synthetic identities. To uncover such fraud rings, it is essential to look beyond individual data points to the connections that link them. No fraud prevention measures are perfect, but by looking beyond individual data points to the connections that link them, your efforts significantly improve. Neo4j uncovers difficult to detect patterns that far outstrip the power of relational database. Enterprise organizations use Neo4j to augment their existing fraud detection capabilities to combat a variety of financial crimes, including first-party bank fraud, credit card fraud, e-commerce fraud, insurance fraud, and money laundering. And all of this is done in real time. Our next use case is network and database monitoring. The size and complexity of network and IT infrastructure require a configuration management database, also known as a CMDB, more powerful than anything relational databases have to offer. Using Neo4j CMDB graph databases, you can correlate networks, data centers, and IT assets to help with troubleshooting, impact analysis, and capacity or outage planning. A graph database enables you to connect your many monitoring tools and gain critical insights into complex relationships between different network or data center operations. From dependency management to automated microservice monitoring, the uses for graphs in network and IT operations is endless. Our next use case is recommendation systems. Making relevant recommendations in real time requires the ability to correlate the product, customer, inventory, supplier, logistics, and even social sentiment data. Moreover, a real-time recommendation engine requires the ability to instantly capture any new interests shown in the customer's current visit, something that batch processing can't accomplish. Matching historical and session data is trivial for a graph database like Neo4j. The key technology in enabling real-time recommendations is the graph database, a technology that is fast, leaving traditional relational databases behind. Graph databases easily outperform relational and other NoSQL data stores for connecting masses of buyer and product data and connected data in general to gain insight into customers' needs and product trends. Our next use case is master data management. As businesses become more customer-centric, it has never been more urgent than today to leverage the connections in your data to make timely operational decisions. This requires a technology to unify master data, including customer, product, supplier, and logistics information, to power the next generation of e-commerce, fraud detection, supply chain, and logistics applications. Neo4j Master Data Management, also known as MDM graph databases, enable the creation of a 360 view of your master data made available in real time to all your operational applications. Such a 360 view can be created either by managing all your master data inside a single repository, or by creating a shared metadata repository to support activities ranging from e-commerce to customer support. Our next use case is social media and social network graphs. Whether you're leveraging declared social connections or inferring relationships based on activity, social graph databases such as Neo4j offer a world of fresh possibility when it comes to creating innovative social networks or integrating current social graphs into an enterprise application. Social media networks are already graphs, so there's no point converting a graph into tables and then back into a graph again. Having a data model that directly matches your domain model helps you better understand your data, communicate more effectively, and avoid needless work. Using Neo4j improves the quality and speed of deployment for your social network application by reducing the time you spend data modeling. Our next use case is identity and access management. Managing multiple changing roles, groups, products, and authorizations is an increasingly complex task at an enterprise organization. Using Neo4j, you can seamlessly track all identity and access authorizations and inheritances with substantial depth and real-time results. This interconnected view of your data gives better real-time insights and controls than ever before. Neo4j connects your data along with intuitive relationships, so identity and access management happens quickly and effectively. Our next use case is data privacy, risk, and compliance. Since the global financial crisis of 2008, regulators have established LEI and BCBS 239 standards for recording, aggregating, and tracking financial transactions. Neo4j helps banks to meet these standards by enabling risk assessment, data lineage, and understanding of dependencies on other systems, investments, and financial houses. In addition to BCBS 239, compliance of FRTB, or the Fundamental Review of the Trading Book Regulations, are required by banks by January 2022. FRTB creates specific capital reserve requirements for bank trading desks based on investment risk models. You can foolproof your risk management and compliance infrastructure using graph technology with Neo4j. The new California Consumer Privacy Act, or CCPA, imposes stiff penalties on those that misuse and resell consumers' private information as of January 1st, 2020. Enterprises need a future-proof solution to leverage data connections, track data lineage, and mitigate any risk of data misuse. And this can be done with Neo4j. Our next general use case is AI and analytics. Today's businesses are faced with extremely complex challenges and opportunities that require more flexible and intelligent approaches. That's why Neo4j created the first enterprise graph framework for data scientists to improve predictions that drive better decisions and innovation. Neo4j for graph data science incorporates the predictive power of relationships and network structures in existing data to answer previously intractable questions and increase prediction accuracy. From pointers to patterns to predictions, Neo4j offers such breadth and depth of advanced graph analytics and data science capabilities in an integrated enterprise environment. Neo4j's efficient property graph model stores nodes and their corresponding relationships together, so you just follow the pointers for real-time queries. The Neo4j graph algorithms inspects global structures to find important patterns, and now with graph embeddings and graph database machine learning training inside of the analytics workspace, we can make predictions about your graph. Our next use case is supply chain management. The customer is now at the center of the value chain. However, real-time control of inventory, payment, delivery systems, and overall responsiveness is complicated, especially if you're slowed down by legacy infrastructure. Neo4j addresses these challenges with graph database technology. Maximizing cost visibility is also a common goal for large organizations, but it's one with a number of growing data management complexities. The U.S. Army uses Neo4j to track, manage, and analyze operating and supporting costs for weapon systems across the logistics community. Our last use case is the knowledge graph. And this is the most popular use case for Neo4j. A Neo4j knowledge graph is an insight layer of interconnected data enriched with semantics, so you can reason with the underlying data and use it confidently for complex decision making. Only graphs excel at managing connected data and complex queries because relationships are at the core of the data model. Knowledge graphs add an additional layer of context to deepen the connections. And knowledge graphs are so popular for Neo4j that two-thirds of all customers have implemented one. Some other use cases that weren't listed on the slides include telecommunications by managing complex interdependencies, IT infrastructure, and other dense networks using Neo4j. The government also uses Neo4j to fight crime, prevent terrorism, improve fiscal responsibility, boost efficiency, and provide transparency to citizens. Pharmaceutical companies, chemical manufacturers, and biotech companies use Neo4j to analyze data in ways previously not possible without graphs. Financial services use Neo4j because from risk management to security recommendations, context is key, and top banks around the globe use Neo4j to solve their connected data challenges. If you want to check out more use cases or some of the use cases more in depth, you can go to the Neo4j website. Under the top tab Solutions, you can click on Use Cases to see more. The next area is industrial adoption. There are hundreds of different companies that have adopted Neo4j and use them on a daily basis. I will go over just a few of them for you. Lyft uses Neo4j to speed up data discovery. A Fortune 200 IT services company transforms and accelerates customer engagement with real-time matching of capabilities to client needs. NBC News analyzes hundreds of thousands of tweets using Neo4j. Caterpillar, which is a construction, machinery, and equipment company, uses Neo4j, which provides natural language processing at scale, making equipment repair more efficient. Airbnb uses Neo4j for master data management, which empowers a global network of Airbnb employees. An ad tech agency uses Neo4j for identity graph analysis at scale, which provides the ad tech agency customers with a greater return on investment. A global 50 bank uses Neo4j's graph technology and AI to help them lend money in Latin America. Kerberos, an online security company, uses Neo4j for money laundering prevention. Perform Media uses Neo4j for a graph-powered single customer view, which improves data monetization. Cisco, one of the most popular IT companies, uses Neo4j for a real-time graph analysis of documents, which saves the company over 4 million employee hours, which is easily tens of millions of dollars saved by Cisco. Lockheed Martin Space uses Neo4j to tackle disparate lifecycle data from scientists to satellites with a Product 360 system. eBay uses Neo4j to power intelligent commerce for the eBay app on Google Assistant. And as previously said, the U.S. Army uses Neo4j to keep the Army running by tracking equipment maintenance. And you can see many, many more industrial adoptions, or you can see some more specific examples in depth on Neo4j's website under the Solution tab when you click on Customers. Now onto some of the limitations of Neo4j. Looking up multiple nodes in Neo4j is not very efficient, as it is more optimized for looking up relationships between nodes. So a relational database would be better if you're trying to look up many, many different nodes. There is no security at a data level because there is no data encryption. So sometimes security can be an issue using a graph database. Neo4j has a limitation for the number of node properties and relationships. This is a limitation, but only for some of the most massive companies as like Google or Amazon, where any company smaller than that should not run into the upper bound of nodes and relationships. Neo4j has a master-slave architecture in which all actual data resides in the master database, so all writes happen through the master. So in a case of a large number of writes, this creates a bottleneck in which only one node can process the queries. So this can be a problem because there is no load balancing, because all queries must happen through the master database. Going off of this, Neo4j does not support sharding, which is a way of horizontally scaling your database by splitting up a large database into several smaller databases. So this can be a problem when dealing with very large complex data sets. As well, in Neo4j, all data resides on each machine, and so you need the data in memory if you want to avoid expensive disk seeks, which take much, much longer than if you had the data in memory. So this can cause problems for performance when the amount of data exceeds the RAM capability of the machine. And next we'll be talking about some of the differences between a few of the other programs out there. First, we'll be talking about TigerGraph. So Neo4j has a faster loading time than TigerGraph, but TigerGraph has a faster pre-processing time. Neo4j supports many, many more languages than TigerGraph. Neo4j supports .NET, Clojure, Elixir, Go, Groovy, Haskell, Java, JavaScript, Perl, PHP, Python, Ruby, and Scala, where TigerGraph only supports C++ and Java. And lastly, TigerGraph is much faster than Neo4j when executing hop queries, and especially multiple hop queries. Next is MongoDB, where Neo4j is a graph database. MongoDB has a different structure called a document database. Along with that, where Neo4j has no aggregate framework, MongoDB does have an aggregate framework, which is a pipeline framework used for transforming data. Neo4j enables navigation through graphs and provides visualization, where MongoDB cannot provide visualization due to it being a document database. And lastly, Neo4j and MongoDB are both schemaless databases. Next is Cassandra. Neo4j can be written using Java and Scala, where Cassandra can only be written in Java. So Neo4j can be a little more versatile in that respect. Neo4j has foreign keys, where Cassandra does not have foreign keys, or the concept doesn't exist in Cassandra. Neo4j does not support sharding, where Cassandra does support sharding, which is a huge advantage over Cassandra for those medium-sized companies where you will not have that bottleneck of the master-slave architecture. And lastly, Neo4j supports Linux, Mac, Solaris, and Windows, where Cassandra supports Linux, Mac, Windows, and BSD. And that is the last of the comparisons. Thank you for watching the tutorial of Neo4j, and I hope you have a great day.